Welcome everyone to the Linux and Git workshop. Um, so let's get straight into it. So this is the recording after, where the recording in person, sadly, there was no audio. So most of this I recorded a couple weeks ago and then got very busy, and I just wanted to record the intro here. Most of you might know this, but Linux is a open source operating system created by Linus Torvalds in 1991. This is sort of the basis for a lot of what computer systems are run on today. Even systems that don't look like Linux are often based on Linux because it's open source. So anyone can take the code and then make something else out of it. For example, like Android is based on Linux. I believe Mac OS is based on the Unix system, which is sort of part of I think it predates Linux, but it's part of that same family. But yeah, there's two main parts. There's a kernel, and that's the kernel is like the lowest level software. That's written where it interacts with the memory, it interacts with the cache, figuring out where instructions go. And then on top of that, there is user programs, and those interact with the kernel. Those say, hey, I would like to create an integer, and the kernel then says, okay, I'll find space for the integer, that kind of thing. Um, there's a lot of system libraries. The GNU C library, which is very popular. Um, but yeah, there are other ways to set up Linux where it's not just C and a kernel where you have the terminal, but there's distributions where people made interfaces that look like Windows or Mac OS, which are called distributions. So they are bundled with the kernel and they provide a much more complete operating system experience. They'll often include like a package manager and a shell, so you can install programs and use the command line. And they're much more trying to be like operating systems, especially popular ones like Linux Mint, which are really essentially trying to be user-friendly operating systems for anyone just running on Linux. Here are some of the most popular ones: Ubuntu, Debian, Fedora, Mint, Arch. Mint, by the way, is what Linux Mint is built on. So each one builds on the other because most of them are, I think most or all of them are all open source. So someone likes something about one of them and then builds their own version of it. Um, I believe our coordinator Simon uses Arch Linux. But yeah, there's all sorts of Linux distributions. And then those are just collections of software. And then built on top of those will be desktop environments. And that's the graphical user interface that uses all the programs in the distribution and presents it to you nicely. So that's where the Cinnamon is built on the Mint distribution of programs to give you this beautiful interface. And there's all sorts of other ones that you can get. So yeah, you can take a look at these links. So feel free to click on all these links and take a look at different desktop environments. And you can go to the Fedora project and see all the different distributions and desktop environments. It's great. And yeah, Linux is pretty important because it's basically the whole world runs on Linux. You know, this website here, GitHub, right? This is or this video that you're watching. These are hosted on computers somewhere, massive servers of just thousands and thousands of computers, terabytes, exabytes of data, who knows how much. And that needs to run on some system. It's not Windows, it's not Mac OS, it's usually Linux, probably a custom version of Linux built for that server, in which it's super efficient. There's no there's no Microsoft Word, there's no other programs. All it does is it does its server thing. It stores and fetches and sends and receives videos, or it hosts web pages and data and databases. Yeah, so it's really fast, really secure. And yeah, interesting stat here. 96.3% of the top 1 million web servers are running on Linux. So it's pretty important to know Linux. You may not code directly for Linux, but it's good to understand how it works because most of the things you write, especially if you're writing for the web, are running on Linux, whether you know it or not. So it's good to learn, and it gives you a much better fundamental sense of how the computer works. Like I enjoy learning Linux because it helps me understand Windows better when I'm navigating through the file system and using folders. In my mind, I can understand that there's memory locations and it's typing in, I can imagine the commands being typed into the terminal saying, go to this directory, and then the kernel is fetching a certain memory location and returning the contents in that memory location, and then they're being rendered graphically to you. But underneath it all, that's what's going on. So it's a great way to learn. Installing Linux is a bunch of different ways. So there's a way to do it using the ISO. That's like an image that you burn onto a disk. You can also download these images and burn them onto little flash drives, and you can put them into your computer and then boot off of that and install them. So yeah, so once you install one of these, you can put them on a USB flashing program, which again, we have links here for you to take a look at. But installing it on your machine is kind of a big thing because either you're partitioning your hard drive, so like half of your hard drive now runs Linux instead of Windows, or you're like getting rid of Windows. So it's kind of a big thing. So you can set up a virtual machine, which again, there's links here. You can get the Oracle VirtualBox and you can run it on a virtual machine, and that's a little bit less involved, and then you can play around with it without it messing up your system. And the easiest way to really do this is using WSL versus WSL, Windows Subsystem for Linux, through Windows. And here is where past me will take over. All right, welcome back to the Linux and Git workshop. Sorry about the technical difficulties where we had no audio on the original recording. So I'm back, your friendly neighborhood computer peer teacher, Mayor Manovich. We should be up to here, where we're installing Linux via WSL. So WSL is called the Windows Subsystem for Linux. And what it does is it installs Linux as just like a program on your computer. And it works for Windows only. So it's the I would say, least invasive way to use Linux on your computer if you're using Windows, right? It doesn't partition your hard drive. You're not booting from an ISO image. It's just a program. You don't have full control. Windows does retain, control of the system, but you can do most things you want to do with Ubuntu, especially if you're in CIS 345 or 340 and you want to be compiling things with the GCC compiler and running programs similarly to how they would run on Grail. So to do this, and then throughout the video, this is going to be a little bit faster. So feel free to just pause and do these things on your own and see if they work. So you're going to open up WSL in your terminal administrator mode. Okay, so you're going to go to the terminal in administrator mode and type WSL -- install. And that should just start installing. It'll take a while. And once that's done, you restart your computer and it should pop up. Give it a minute, but the terminal should pop up and say, hey, Ubuntu is installing. If it doesn't, open up the terminal and that should get it to go, but it should complete its installation and then prompt you to make an account and a password. And once that's done, you can then type in the update and upgrade command. And what this does is it executes two commands at once. It updates the system and it upgrades all the packages if there are newer versions. And the -y is to answer yes. So when you're updating packages in Ubuntu, it often stops and says, hey, are you sure you want to install this? Yes or no? And you type in, Y and hit enter. So if you're sure you want to update and upgrade all of your packages, which I don't know if there's a reason not to, you just type -y and it just answers yes to everything. And once that's done, you can close the terminal and open it again. And now you're ready to use Ubuntu. Once it's installed, there's a few ways to access it. It's called Ubuntu or WSL from the start menu. You can type in Ubuntu or WSL, or you can go into the terminal, like the Windows terminal, and type in WSL and just execute, or Ubuntu. Or there is a drop-down menu. So I'll show you my terminal window. This is WSL already. But if I go to a normal terminal window, which you might see Windows PowerShell, there's a little drop-down bar here. And you can see there's different prompts I can open. And one of them is Ubuntu. This is what you're going to click to open up your version of Ubuntu running on the Windows subsystem for Linux. So that's pretty much it. It's a great way. I highly recommend it for people who need to write and compile a lot of C programs because GCC works natively and it just works really, really well. That's about it for WSL. So let's get straight into it. The last thing is that you can use the Google Cloud Shell if you have a Google account, which I'm assuming most of you do. You can go to shell.cloud.google.com, which looks like this. Or it'll be a little bit, it'll have this like VS Code kind of interface. And then you have this shell here, which is a sort of a virtual Linux system, which you can then run and use to run all these commands. So if you don't want to partition your system or use a virtual machine or use WSL, or you're on Windows maybe, sorry, you're on Apple maybe, and you would like to just try things out along with me, go to shell.cloud.google.com and you can test all of this out and dip your toes into the system. So that's really fun. All right, let's get straight into it. Let's run our first command. This is going to be fun. Let us run our very first command in Linux. So pwd. What this means is print working directory. And you can see it prints the working directory, as you're familiar with the word print, as we use to say just like show it to the terminal. You can see in WSL, and I will mention this actually, for those of you who are not, those of you who just installed WSL, you will not be mounted. So WSL installs Linux as sort of like a program, and it needs to first access your C drive to even work. So you will probably be here. Yeah. And you don't have your C drive when you first start WSL. So you need to change your directory by hitting CD, and we'll go over this soon. And you hit /, which is the root, and then MNT, and then /C. And this will get you into your C drive. And then I went into my user on this computer into my desktop. So pwd prints our working directory. So this is useful anytime you're anywhere to see where you are. Now, there's a couple other essentials before we even get started. These are things you'll be using all over Linux. ls is list. List what is inside my C drive or any directory you are in. And again, you can know which directory you're in using the print working directory command, and then ls to see what's inside. So this will list everything. You can see that Windows is restricting some of the access to the files, which is how it works. So we can't access the paging file and the hyper file and the swap file, but that's okay. So list is very important to see what is in your directory. When you're changing directories and things, tab is an autocomplete system. So if I would like to go to, let's say, to program data, I can say cd, which is change directory, and I can start typing program data, PRO, and then hit tab. But this won't work right away because I have multiple files here starting PRO. I have program data, I have project 32, I have program files and program files. I have a bunch of folders. So when I hit tab, nothing happens. But if I hit tab again, it shows me all of the options that start PRO. So let's say I wanted to go into the project 32. I'll type in J, PROJ. Now there's only one option with the J, so if I hit tab, it auto-completes. So this is very, very useful. Once you know what your files are named and you want to just like fly around the system, this is really, really useful to always be hitting tab. That's useful. The dot and dot dot, which we will go over soon, but dot across the whole system represents where you are. So obviously that's not useful with the change directory command because you are in the directory you are, so you're not going to change the directory to your current directory. But let's say you want to move a file to the current directory, dot represents the current directory, and dot dot represents the one above you. So think of your directories as a hierarchy, right? So like the C drive is all the way up top, and then things are coming down like a tree. We got your users, you got your system files in the users. We go further down, you've got your username. Further down, you've got your desktop and your other files. So if we say change directory dot dot, notice that right now we're in project 32. It's going to go to the directory above project 32, which you can see by looking at the file path is before that slash, which is before the project 32. So we're going to go back to the C drive. And you can see in our working path right now, we're back in the C drive. And you can always type pwd to see the full path and ls to see what's inside. So yeah, tab is autocomplete, very helpful. Another very helpful thing to be using all the time in Linux, if you're using it, is the up arrow. The up arrow will bring up the command you just did, so ls, but it has a whole history. So you can go again, pwd. And let's say I want to go back to project 32, but I don't want to type in CD project 32 again. I don't even want to do the tab. I have no time for the autocomplete. Just type up a few times, and there we go. CD project 32, enter. And then let's say I want to go back to the C drive. I hit up a few times, CD dot dot is already there because I already did it, and hit enter. So the up arrow is very useful, especially if you have like a long file path you once executed and you want to change one part of it. That's very useful for, you can bring up the whole thing instead of typing it in again, and then you can delete some of it and change what you need. So very useful. Up arrow has a history. I think the history goes, I'm not sure how much history it keeps, but it sometimes keeps a fair bit, especially on the Grail computers, Grail, Spinit, Spirit, and then all the subsidiary computers, Beethoven, Bach, Chopin, Haydn, all those computers, because I think those are always running. So I don't think it deletes the history very much. So if you like log into Grail today and you type up arrow in the terminal, it will like bring up, commands you executed like last week, which is really cool. And then the last thing, which is a really fun demonstration here, is Control C. Control C is your friend because Control C allows you to stop any command that's running. Very quick demonstration. I want to show you two things. One is cat. The cat command we'll go over later, but it just displays whatever you give it. So you can type cat and give it a file, and it will show you everything in the file. But if you type cat with no argument, so just cat, and hit enter, it then enters into this nothing, where you have no more like prompt for another command. And if you type something and hit enter, it just repeats it back to you. And you can't do anything. You can't type ls, you can't type cd, you can't change directories, you can't get out of it. But you can type Control C, which cuts the execution of the program cat. So Control C, and we're back to the command. And I will show you a quick demonstration of this in a fun way. If I go to my users and desktop, sorry, I have to go into my account first. And I'm using tab, by the way, to autofill these things. And I'm going to make a directory, which again, we'll go over soon. Make directory, and I'm going to call it Linux testing. And I'm going to go into that directory by just typing cd and then lin and tab autofill. And in this, I'm going to create a new file using nano, which we will talk about in a moment. Nano, and I'm going to call it loopy.c. And here, I'm going to make a very basic C file. So any of you have seen C, you will be familiar with what you're seeing here. I'm going to bring in the standard input-output library, make that a .h. I'm going to include the standard Boolean library, which you will be familiar with, I hope. Standard bool.h, and then we'll make our friendly main function. And in the main function, we're going to do something that you're probably told never to do, which is write while true. And for those of you who have taken probably 260, maybe even ESC 151, you'll be familiar that while true will never become false because there's no condition to make it false. While true, well, what is true? True is just an abstract true, so it will always be true. We can then say in here, print f, and all caps, help! I'm stuck in an infinite loop. And then our closing parentheses, and don't forget the semicolon. And then I don't think we need to, but it's just good programming principles to hit return 0 semicolon. We save it using Control S, Control X to exit out. And this is what I'm talking about. You can just use GCC natively. GCC loopy.c, and then I can type -o to specify the name of my executable. Otherwise, by default, it'll be a.out, which for those of you who've used GCC before, hit enter. We have a slight error. What was my mistake? I wrote return instead of return. No problem. I'll go back into nano of loopy.c. I will go to the return statement. We'll add an R, save it, exit out. Oh, use the up arrow now. See, I'm using the up arrow because I just want to execute the GCC again. And now it works. And if I type ls to list, I now have a loop. /loop, for those of you who know, that's how you run a C file, an executable in Linux. And here we go. Yeah, it's not great. So if I type Control C, it stops it. So Control C is your friend. Control C lets you get out of stuff. And then when you have tons of text like this, you can type clear. CLEAR, and just hit enter. And it will bring you back to the top. Make the text a little bit bigger. All right, so those are your Linux everyday essentials. That's what we're going to be using this throughout the entire workshop and probably throughout your entire time using the Linux terminal. It is quite useful to know these things. Print working directory, which I don't use as much because usually the directory printed here is enough. ls, always, always. I go into a directory, ls. I always just want to go somewhere, what's inside? Go somewhere, what's inside? And then I use change directory all the time, tab and up arrow all the time. And then control C, very useful. Now, the root, we can go to the root, and there's a difference between root and home. So this is an important distinction in Linux. There's an idea of the root, and there's an idea of the home. The home is going to be the user's operating, basis. That's where your desktop is, your files, your pictures, your videos. The root is the origin of the entire computer. Okay? So that's like where the inside, from the root, you have the kernel, you have the operating system, you have all the programs, all the system files, all the settings. That's what the root is. To go to the root, you just type /. So cd /. And if you're using WSL if you're using WSL and you type ls, it will show you something that looks like a Linux system. For those of you who've used Linux, you will notice this looks a little bit familiar using the bin and the lib64. I actually don't know if this is on the computer. It might be installed as like a virtual Linux, root in the computer, but it is not the root of your Windows computer. But this is what the root of a Linux computer would look like. And then from here, you would have to then, again, mount the C drive. But we don't have to, because we can say cd and home. And now, what this is going to do, if we print the working directory, cd home, wait. Oh yeah. So we're in the home directory from the root, which you can see in our ls was one of the directories in the root, right? We can also go back to the root by hitting cd ... which again is always the level above us. Cd and then tilde will always bring us, oops, I hit the wrong thing, pwd. cd tilde will always bring us to our home, like our user home base, not the root. So cd / is the root, cd tilde is like where you'll find your desktop and stuff usually. Again, for WSL, you will need to go to the root and mount the C drive, which you can do anywhere by hitting cd / mnt / c. Okay. So this is an idea which we're touching on here, which is you can move multiple levels. So cd takes any file path. So you can be anywhere in your computer, and if you say cd /, you're telling the computer, I don't care where I am, I want you to move to a directory starting from the root. It doesn't matter where you are. You start from the root, this is where you're going to be. You can also do that from in a directory using going up levels and then back down levels. So if we're in the root and we go cd home, once we're in home, let's say I wanted to go not to the home, I wanted to go to the lib folder in the root. I can say cd and ... will bring me up one level to the C drive, to the root drive, and then I can say / and then back down lib. And is lib one of the folders? Let me scroll back up. It was lib is one of the folders. Perfect. And I can hit enter. And now I'm already in the lib. So in one command, I went from home back up to the root, back down to lib. And you can do this as many times as you like. So in lib, I just hit ls to see what's in lib. I can go to, let's say, gcc, so cd gcc, and now I'm in gcc. And now I can type to go back to the root, cd ... So now I'll go back up to lib, / ... I'll go back up to the root, / home, down to home. So you can change as many of these as you like to always get a path. So if you start without the /, the path will always be relative to you, right? So if I'm in GCC and I type ... then I'm going up from GCC. But anywhere, if you want an absolute path, just start with the /. / will tell the computer, I don't care where I am, start at the root, and then there's a file path. So that's very useful. if you know the path of a file and you don't want to be going up, up 10 levels and down 11 more levels. You know where it is. So that's pretty useful. So yeah, we've covered the multiple levels. We've covered the forward slash, which is the root. Um, and then the tilde will always represent your home. So you can use that in conjunction with other paths. So if you know something's at your user home, you can type cd tilde forward slash something else if you know what's in there. All right, so let's go to our, whatever directory you're comfortable creating new files, right? Let's create some new files. So I'm going to go into cd and then go to the root. I'm going to type mnt c users and then my user, my desktop, and I'm going to go to the Linux testing folder. And in here, let us make some files. You can go to every directory you like. And to make a new directory, we type mkdir. This stands for make directory. And mkdir takes an argument as a file name. But the file name can also be a path that ends in a file name. So I can just type in like a folder right now. So let's say I'm going to call my new folder beep. So just mkdir space beep. If I type ls now to list what's inside Linux testing, we can see there is a folder beep, which is highlighted, which means it's a folder. If I wanted to create a new folder inside beep, I can do that from Linux testing by just typing mkdir beep forward slash, and now I type my new name. I'm going to call it boop. And if I type ls, I see beep. I can change directory into beep. And in beep, ls, there's boop. I'm going to do cd up one more directory back into Linux testing. Right? So you can make directories wherever you like. The last name should be the name of your directory. If you type in the name of directory and you just, there's a way to rename directories. I think, oh, that's later. That's later. Okay, we'll go over that soon. First, mkdir can take in multiple arguments. So you can type in mkdir make directory, and I can say, red space blue space fish. What this will do is create 3 folders: red, blue, and fish. I hit enter, I hit ls to see what's inside my Linux testing, and we've got red, blue, and fish. Now, I hear you say, wait, what if I wanted to have red, and inside red I want to have blue, and inside blue I want to have fish? No problem. What we can do is type in mkdir -p. So this is an introduction to options. mkdir and options are ways to customize any command in Linux. So any command you type, you can always type after it --help to see a list of all the options. So if I type mkdir space --help, we can see we have a few options: -m, -p, -v, and -z. -p is parents. What it does is it makes all of the folders we're about to say parents of each other. So typically, if I say mkdir and I say, let's say purple, and then orange, and then turtle, and then penguin. What it would normally do is look for a folder called purple. Inside that, look for a folder called orange, look for turtle, and then create penguin. But we don't want to do that because those folders don't exist. We want to create all of these folders nested. So we hit the -p. And by the way, what I just did is use the arrows to then navigate through the text that I'm typing before I'm ready to execute. So I add the -p before the name. And what it's going to do now is create purple, and then orange, and then turtle, and then penguin all nested. Boom. Type ls. We have a purple folder. We can go inside purple. Inside purple is orange. Inside orange is turtle. Again, all of these I'm hitting cd and I'm typing the first letter and hitting tab because there's no other option. And inside turtle is penguin. And inside penguin should be nothing. There we go. And because I've just done, I believe it's 4 folders, I can do cd goes upper folder to turtle, /, up to orange, /, up to purple, and /, up to Linux testing. And there we are. We're back at Linux testing. So that's the situation. And then renaming a folder is not too bad. You just, is this renaming? This is, creating things with spaces. So yeah, Linux does hate spaces. Linux cannot handle spaces because think of Linux written as a program, right? So what they wrote as this program, and you may have written programs like this in your early programming classes where you had to delineate text by the spaces. In Java, maybe you might be familiar with the dot split, like a string dot split, which is a command. It's a built-in function. And what that does is it tells the computer, I want to split all of this text into multiple commands. So you give me multiple things, and I look at each word as a separate command. That's what Linux is doing. So if you say mkdir and I want to call it beep boop, beep space boop, this is not going to create a folder called beep boop. This is going to create two folders because Linux sees two arguments. To tell Linux, hey, 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 stop looking at the space here. This is not for you. This is for me. You need to use quotation marks. Okay? So use quotation marks. What this is going to do now is it tells Linux, hey, there's only one space here. There's a space between mkdir and the name. The space inside the name is for me, not for you to delineate. If I hit enter, we hit ls, we have a folder called beep boop. Perfect. So that's your briefing on making folders. It's pretty cool. We have gone over ls for listing files, but how about redirection? This is a kind of a fun thing. We'll touch on it more later. Redirection is really cool. But you've noticed so far is when we hit ls, we get a list of all the files. But what if I don't want to get the list of files? What if I would like to create a new file with all of the names of the things in my current directory? Well, we can totally do that. We can tell Linux, hey, don't actually print out the output of this command, but write it to a new file. And we do that using the redirection operator. So you type ls, and then the forward arrow. So if you look next to those of you who are familiar with programming will be familiar with the arrows, but it'll be next to, between your M and your question mark, there should be two arrows there. It's shift. You have to do shift to access them, do the forward arrow, and then you're going to be creating a new file. So let's call it output.txt, output.txt, and then hit enter. And you should see nothing. But now we can use a new command called cat, C-A-T, and then type output, or just OU should get enough, and hit tab. And what cat does, as we did earlier, is you give it something and it will print it out. So if we give it an actual input, like a text file, it then prints out a beautiful list of all of the files and folders in our folder called Linux testing. Beep, beep, boop, bluefish, loop, loopy.c, output.txt, purple, and red. It's gorgeous. So that's redirection. We're going to get more into that at the end, where I'll give you a taste of pipes, which is a wonderful, wonderful thing, which you may have or will work on if you're in 340, where you're going to be using pipes to communicate between different programs. But this is the fundamental, the base underneath all of that in C, or Linux is kind of idea of pipes. So we will work on that later. But that was just a taste. So cat is the way to see files. Very, very simple, not as complex as nano. And again, a very simple way to write to files is echo. But again, we're using redirection because there's a command called echo. If we type in echo and then you type in quotation marks and anything you like, so here's a bunch of strings, and then I type out ending quotation marks, you have to remember both quotation marks. If you execute this echo, it will then echo, surprise, surprise, what you just wrote, kind of like the cat. So what we can do is type this command again. So I'm going to hit the up arrow to access what I just did, and then hit a redirection. So instead of echoing it to me, echo it into a file, please. So I'm going to call this file test_1.txt. Test_1.txt. And then we can do that again for something else. I'm going to just hit the up arrow to edit the previous command. I'm going to make a new file called test2. So I'm just editing the two. I'm using the arrow again. I'm going to edit the text inside the quotation marks. I'm going to type a new string of just gibberish, hit enter. Do it one more time. I'm going to call this test2A. And you'll see why in a moment. I'm going to type in some new gibberish. Great. If we type in ls, we got a bunch of text files here. Test1, test2, test2A. If we would like to view the combined contents of all three files, we can type in cat And cat can take in multiple things. Cat doesn't care. Cat's not like a file viewing and editing thing. Cat is just like, give me some text, give me something, and I'll show it to you. So we say cat, and we can say test underscore one.txt. And then it makes a space, and we can just say another file, test2.txt and test underscore 2a.txt. And it will show all 3 lines of text. It doesn't care. We can also, because cat doesn't care about all 3 files, we can create a new file, which is the combination of all 3 files. So we can bring up that command we just did, which is the cat of all 3 files, and then redirect the output into a new file called combined.txt. And now we have a new file. If we say cat combined.txt, we have one text file that contains the contents of 3 other text files because we used redirection on the cat command on 3 different files, which is kind of cool. Now, for lots of different files with different names, this is a big Linux, huge like Linux concept. Again, kind of like how dot and dot dot are big Linux concepts across all Linux. Where dot represents where you are and dot dot is the directory above you. Question mark and star are concepts in Linux where question mark will replace one letter in your name, in the folder, in the file name, anything that you're doing, and star will replace everything after it. So I'm not quite sure how to explain this, but by showing you. So if I told it cat and then test underscore question mark dot txt, what do you think this will grab? Well, look at it. Test underscore question mark. It will look for any file that follows this pattern. It says test underscore, and then it has something there. It doesn't matter what character, any character dot txt. So notice test underscore 2a would not be included in this because 2a has 2 characters. So if we say cat underscore, if we execute this command, we have 2 lines of text, which is the first 2, but not 2a. And similarly, if we do question mark, this will only grab 2a, since test 1 and test 2 only have 1 letter between the underscore and the period. So there you go. That's the text in the test 2a. But if we do test underscore star, and we get rid of everything else, so get rid of the .txt, just test underscore star, it will replace everything, so including the .txt, just any file in the Linux testing folder that begins with test underscore. That's it. And there we get all 3, because there are 3 test underscore files. They're all text files, and they all work. So these are big Linux concepts. The question mark replaces 1 character, and then, and the pattern before and after the question mark need to be the same. And the star replaces everything after the pattern that you've put before it, and it will grab everything with that starting pattern. So good Linux things to know. And then a couple final text manipulation things is we can append text to a file. If we do echo, actually, I'm not going to type it all out. I'm going to use my up arrow history to bring up a previous echo command. There we go. That's an echo. And we can use 2 redirection, so 2 arrows in front of each other. So you say echo, you have your text, and then instead of 1 forward arrow, we do 2 forward arrows pointing to the right. This will append text, and then after the 2 arrows, you need to write an existing file name. And then if we do cat of test 2a, you can see that it now has 2 lines of gibberish because we just appended a line to it. And the last thing is you can use the command less to view long files of text. So instead of cat, you can use less. This is useful for when you have like entire pages of text. I can demonstrate this quickly if I go back to my desktop. So cd ... And then in my desktop, I think I have a big cd, I think it's reduce. And then in reduce, I have a big C file here. CD, it's not that big. THR atomic. CD. Oh, I can't do CD, I'm sorry. Less, here we go, less THR atomic dot C. This will show me atomic.c as a whole file, and you can navigate using less, using the up and down arrows to do 1 line at a time. Or we could do space for an entire page and B to go back up a page. So when I hit space, print F, this line is becoming the top line. And it's so like the then lock is underneath that print line. And we can keep going down page by page, back up using B, B and space, or using arrows to go up one line at a time, up and down like that. And to get out of less, don't panic because Control C doesn't work. Hit X, I believe. Or is it Q? Oh no. It's Q. My bad. Hit Q and you're out of there. Okay? So less, I don't think you'll be using less that often, but it is useful in case you want to just quickly look at large files. But usually when you're looking at large files, you're usually editing them. And that is where Vim and Nano come in. I cannot even start, I can't even touch on Vim and Nano. They are entire workshop-worthy programs of their own. Especially Vim. You may have heard people, it's kind of a thing. People are into Vim. Because Vim has so many keyboard shortcuts that you don't need to use a mouse at all. So people who really get into Vim don't ever, like their hands just stay on their keyboard. Like they know all of the commands, they've memorized them all, and they're just like boop, 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 and they can just move. If you ever watch someone who knows Vim, it's kind of crazy. Like the cursor just flies around the screen and text is just popping up and things are moving and they're not touching the mouse. It's kind of crazy. So I definitely can't touch that. Nano, you saw me use earlier. So Nano is for quick editing and creating files. Both of these you can create files. If you type Nano or Vim and type a file name that doesn't exist, it will create that file. If you type a file that does exist, it will open that file for editing. The only thing I will say right now is if you want to experiment, you need to know how to get out of them. Control C will not work. Nano to get out of it is Control X. And Vim, you need to type in :Q. Okay? So let me show you that. Vim of thr atomic.c. I'm now in Vim, and it does all this beautiful text highlighting, and I can scroll through and all that. Control C does not work. Control X does not work. :Q, enter. That's how you get out of there. And then Nano, I showed you earlier, but nano of thr atomic.c, hit Control X to get out of there. Anyway, Vim and Nano for you to explore if you'd like. Just a note, things are typically case sensitive in Linux, or in just general Unix systems. So be careful with case sensitivity because a file named, lowercase a.text is different from a file named capital A.text. So yeah, it's sometimes easier to just do everything lowercase. So then you just don't need to worry about that, but that's okay. Yeah, and just good practices for naming files is to use lowercase letters, numbers, underscores and hyphens. So underscores make your life easier because you see how you need to use quotation marks. And then imagine you're trying to go into like a file path where the folder, like the directory itself, has a space in it. You may have tried this before and it gets mad at you because it thinks it's two different commands, but it's not. So you need to use like the backslashes or use quotations. It's just a lot easier if you make things with underscores or using camel case. Some people like, that's one of the ways. All right, let's get into some file manipulation. So you have a few files, you have a folder. Let's move some things around, right? So we can, let me go back to my Linux testing. In here, I have a few folders and I have a few files. If I wanted to move, for example, my loopy.c into the fish folder, we type in mv. mv is move. Move takes in a bunch of commands, a bunch of arguments. And what it does is it looks at the last argument. The last argument is your destination. The arguments in between are all of your sources. You can move multiple files. Right now I want to move loopy.c, so loopy.c. So that's the source, and the destination is fish. And it just moved loopy.c to fish. If I type in list, loopy.c is gone. If I change directory to fish and list the files in here, there's loopy.c. I can move multiple files again. So if I type in mv and I type in test underscore 1.txt and test underscore 2.txt, and then I type in fish, it just moves both of the files. You can see they're both gone. And if I go to fish using cd and fish, ls, there are all my files. If I wanted to move all of my files out of this directory, here's the first time we're going to use the dot. So I'm going to go back in the directory I want them in, and I'm going to say move, and then I'm going to type in the file path. So again, this is another big concept in Linux. Anytime you're dealing with files or file paths, you can always use entire file paths. So the move command works anywhere, and you can just, I can say move and then start with a forward slash, and this is going to go to my root. So it's going to be looking for files to move in my root. It doesn't matter where I am, as long as I know the file path. So if I know in Linux testing there's a folder called fish, I can say move fish forward slash, and then I want to move all of the files in fish. Well, we learned about the star character. Star character will replace all of the characters of any files. So it will basically take all the files. And now I want to tell them to move it to my current directory. To do that, we type in just one period. This represents the current directory. Hit enter, ls, all of the files are back here. We change directory back into fish and hit ls. There's nothing there. That is the basic idea of that. And again, you can move across nested directories. The file paths work. So you can move something into a directory, which is in a directory, which is in a directory, which is in a directory by just knowing the file path. And again, relative and absolute are all the same thing. So if you're in a directory that has beep and beep has boop and boop has fish, in the directory you would say move beep forward slash boop forward slash fish. But if you want a directory that's somewhere else, you would need to either go relative to dot dot forward slash dot dot, and you know how many levels to go up and how many levels to go down, or you just start with the forward slash, which is the root, and then use the absolute path. So that's a pretty, yeah, that's how it works. Same thing for copying files, the same exact thing, except the command is CP. CP for copy, and copy takes source, destination, same thing. You just, instead of moving a file, you're copying a file. So that is the situation. And then you can use the mv command to rename a file. So if you give mv command, instead of giving it a destination directory for the destination, you give it the same exact file. It will then, but with a different name, it will rename the file. So here's what I'm saying. If I want to rename loopy.c to loop.c, I can say move mv loopy.c. And then instead of giving it a file path or a destination, I'm just going to write loop.c. What it's going to do now is going to realize, first of all, there's no directory to change. We're in the same directory, and I'm giving it a new file name. This works across all mv commands. So if you give it a different file path and you end in a file name instead of just a directory, it will rename the file ls, and it's called loop.c. Very good. And you can do the same thing for directories, by the way. So rename a directory by just typing the directory name and then the new directory name. So and of course, as you see me doing, we're using ls to verify all of these operations. All right, big danger time. Focus up. Removing files, deleting files. In Linux, there is no trash can. Okay? If you use Linux Mint, there is a trash can. But if you're in the Linux terminal, there is not a trash can. And the trash can, which you will learn, is kind of just like, it's not really a trash can, it's just a folder. On Windows, when you delete something, it just moves it to a new folder, which might have a setting to like actually delete the files every few months, or maybe it asks you. Here we have a simple command, rm. Rm will delete it. It is gone. So be very careful with this command because, yeah, you kind of can't undo it. So rm takes in as many arguments as you like, separated again by spaces, and it will remove all of those files. As always, you can use file paths ending in the files if you would like to remove something that's in a file path that you know. And again, if it's relative to where you are, you type in the relative path. If you want it to be an absolute path, you start with the root, and then you type in the whole file path. So if I wanted to remove, let's say I'm going to remove output.txt, rm output.txt, and here we go, hit enter, it's gone. There's no undo. Output.txt is gone. Now, to remove a directory, you need to type in the RMDIR. So just like MKDIR, now we do RM, remove DIR. But you should understand that this does not work. Linux is very literal. So if I tell it to remove a folder, it will try to remove that folder. But if there's something in the folder, it says, hey, actually, I can't delete this folder because there's something in the folder. So RMDIR by itself only works for empty folders. So do we have any empty folders here? I think red is empty. So CD, red, ls, and you can see nothing is in red. By the way, also, if I don't want to go into red to see what's in it, ls also takes in a file path. I could just say ls red, and it's going to use the relative file path, so Linux testing /red, and you can see there's nothing in there. So if I say rmdir red, it just deleted the folder red, and it's gone. It also works for folders with similar names. So like if you use the star, it will remove all folders that start in folder underscore anything. That's how it works. Now, if you would like to delete a folder with things in it, the way you're used to on Windows or Mac, where you just delete a folder, it deletes everything in it. What that actually is doing on your computer is running a command that looks something like this. Remove Option-R. This means recursively. This is an incredibly dangerous command to use. It's dangerous just because of how it will crawl through an entire folder and delete everything. So unless you're absolutely sure that you want everything gone, and there's nothing somewhere in a subfolder of a subfolder of a subfolder that you actually need, don't use this, okay? Just be very, very careful with remove-r. But if we take a look at my, I think, purple folder, I believe CD, I can just do ls purple. Yeah, purple has orange, which has, fish and then penguin or something. So if I try to do rmdir purple, look at what it's going to say. It failed to remove purple directory not empty. But if I say rmdir -r, it will now remove the entire purple directory with everything in it. So there is another option to use with rm. So, oh yeah, and for removing recursively, you don't do rmdir. You just say rm-r. And rm-r will remove recursively. So that's for a folder. You can't do remove directory-r. It's a remove option. So just a note here. Yeah, be careful when using wildcards with this stuff. So using the star file, there might be some file you forgot that it has that pattern, and it will delete everything with that pattern. You can use the -i option to get an interactive, which makes you confirm each deletion. And I think you can stack these up. So rm-r-i purple. There we go. So rm descend into directory purple, and we can say y. Descend into directory purple/orange, and we type y. So you can see how the rm command works. Descend into directory purple orange turtle, y. And then it says remove directory. So now if it's in a path that it can delete stuff, because penguin has nothing in it. So it's like, okay, are you sure you want to remove penguin? We type y. Are you sure you want to remove turtle? Y. Are you sure you want to remove orange? Y. Are you sure you want to remove purple? Y. Those 7 commands is what remove-r would do in an instant. And it would do this for everything. So I just the other week I saw a video of someone on YouTube who did this. They must have had a computer they didn't care about, where they went into the root of the computer. Okay, it was on a Linux computer. They went into the root and typed. I think they did sudo, so they did like the administrative version of rm-r, and then they just did the /. And then, in real time, the whole computer just fell apart. You watched as icons were deleted. Like the files were just gone. Everything was deleted except for what was left in the RAM, which, by the way, resets once the power is shut off. That's how RAM works. So hard disk is non-volatile, which means the hard disk stays the same even when you shut off the computer. But RAM, you will know, is volatile, which means you shut off the power to RAM, it stops working. And once the computer shut off, everything's gone. If you ever, by the way, accidentally delete stuff that you can't get back, don't touch your computer. There are people who can get stuff back because when you delete something in a computer, usually it does not overwrite the files in your system. What it does is it tells, hey, computer, by the way, right here in this space in memory, you can put stuff here. This is available space for you. That's what the computer does. It doesn't actually change the bits and bytes yet. So if you accidentally, fat finger the RM command with the -R perhaps, don't create any new files in your system. Don't do anything. And go to one of these people. I'm not sure what they're called, but you can look them up. There are these people who can go into like the file recovery people. And they're they're people who understand the very low level of how hard drives work. And they can hook up your hard drive to another computer and try to recover all the files by basically I think they basically find the section of the hard drive which tells the computer what's available and what's not available, and they flip the bits and they say, hey, this is not available. This is space that's being used. So then you can't overwrite it. But hopefully you never have to go into that because that is a nightmare. So please be careful with RM-R. All right, we're almost at the end. So we're going to talk about piping, which is a really cool idea. Piping is like like redirection. Redirection, what do we have? We had a command, ls, which lists all the files in the directory. And then we said, hey, actually, I don't want that output, but give it to this file. That's what redirection can do. Piping is just like that, except we can now put it into another command. Excuse me. So output of one command becomes the input of another command, as opposed to redirection is output of one command becomes the input of a file. Okay? So piping says you just execute a command, all this output becomes the input of a new program, which then has an output. And as you can imagine, you could chain these. So you can have the output of this becomes the input of that, which becomes the output of that, which becomes the input of that, which becomes the output of that. And you can get a lot done in one line with the pipes. So let us take a look. Let us say, in my Linux testing, I want to type ls. And that gives me a bunch of files. But actually, I don't want to read all the file names. That's too much for me. I would just like to know how many files are in the Linux testing directory. Well, there is actually a command for that, which is wc. Wc doesn't actually do that. Word count. Wc is word count. It counts the number of words, bytes, characters, lines, and it has options to choose what you want. So if I type ls, which will then return a list of all the different files and folders in Linux testing. And I hit the pipe command. So for those of you unfamiliar, it should be underneath the backspace button, pipe. And usually you have to hit shift to access the pipe command. It should look like a straight vertical bar. This will then send the output of ls to word count, which will then take in the list of words. It's just like a list of words. And if we type -L, which is the option for lines, it will count the lines that are inputted to it. And ls will give each file or folder on a new line. And then it will count the number of lines, which should be the number of files and folders in our directory, 10. And if we type ls, we can confirm that we have 10 items here. You see 2 rows of 5 items. That is 10 items. So that works great. That's really lovely. We like that. You can also, if you have like tons of files in a directory, you can send it to less to view the large output, right? So if we go into like a system folder with tons of files, you can do ls pipe to less, and that will put you in this thing where you can go up and down pages. Here, it's not useful because we can see all of it. Remember to type Q to get out of that. But here's where it gets kind of fun. So let's go into our, let's see what files we have open here. We have test1.txt. Let's create a new file. I'm going to create a new file. I'm going to go nano. I'm going to say, we deleted combined. Oh, we have combined.txt. And in combined.txt, I'm going to add some new line. I'm going to call it fish, new line, hello, another fish, a beep, another beep, then a boop, then another fish, turtle, and then another turtle. Control S to save, Control X to exit. So combined has a lot of stuff in it now. Well, let's say I'd like to know how many lines are in combined.txt. Well, I can just write combined. I think you just do word count dash L combine.txt. 14 lines. Great. What if I would like to know the unique amount of items in combine.txt? So if I do cat combine.txt and I want to know how many unique things in it, I can send it to a command called uniq, which will then return a list. It won't return how many, return a list of the unique items. But not really. Notice that we have two fishes. We have another, yeah, we have two fishes here. Why? Because we have three fishes. Because unique is used to remove lines that got copy pasted right next to each other. So we can do another thing. We can then sort combine.txt, send it to unique, which then returns a list of all the unique items in combine.txt. But we can then send that to the word count dash L, which then tells us there are 8 unique items in combine.txt, right? So follow the train here. Sort combine.txt returns a sorted list of them. Unique then took, so if we just do, by the way, sort of combine.txt, take a look what that does. That returns everything in combine.txt, but all identical items are next to each other. We set that as input to unique, which returns a new list of only one time of each thing that was repeated. And then we take that list and put it as input into the WC command, and then dash L, which will then count those items, which we're only giving it a subset of everything that's in combine.txt, and we get 8 unique items. So that's a pretty cool thing to do. The last thing we can do with piping that is a whole world on its own is the grep command. Grep is an acronym. I don't remember what it stands for, but you can use grep to search for things. So if you say cat combine.txt and then pipe, so we're sending it, and then we type grep, then you can put in quotations anything you're searching for. So let's say I'm searching for fish. I want to know if fish exists in combine.txt. It will return fish, fish, fish. So we know there's 3 fishes in combine.txt. And I know you're already thinking this. Well, what if we then sent the output of that into another pipe, wc-l? We now see we get 3 as our output because we took cat, we displayed the whole combine.txt, sent it to grep, which took only fishes and outputted 3 fishes. We then sent that as input into WC, which then counted the number of lines and gave us 3. So we know there are 3 instances of fish in our file. That's a pretty cool thing. I think we can use this for like letters too. So if we typed in just like, I don't know, I, there are 4 I's in our file, which we can see there's 3 fish and there should be 1 more I. Oh, there's a few more I's actually, because these are not right next to each other. That's why it's not counting all of them. So that's mostly on piping. And then one last thing before we finish up is the man command. So I told you about help to see all of the options, but man is to see the manual. So man, and then uniq, gives me the full manual for the unique command. Okay? And you can see, you can press Q to quit out of this manual, but you can scroll through, you can see who wrote the command unique, which is really cool. Richard M. Stallman and David Mackenzie, probably in the 1980s, wrote this part of the Unix system. You see the copyright, you can see all the info, and then press Q to get out of there. So man is pretty useful to see what commands do, and then dash dash help after the command just tells you a brief list of what's going on and the all the options. All right, so that's mostly it. Just a note on the Linux terminal. You might already know this, but the origins of this is that before computers had a lot of memory to handle all of this graphical interfacing that we see here with Chrome, which takes up a ton of memory, there were very, very strict memory restrictions on computers. They were using kilobytes. That was a whole hard drive or an entire memory. So what they used was just terminals. That was back in the beginning of Unix. It was just terminals, especially when they were trying to do then like networking with multiple computers all connected. Sending files. This website right here is, we can see with Chrome, is using 65 megabytes of memory That kind of stuff would not have downloaded, over the network in 1980. So, but text could go through because each ASCII character is just a few bytes. Um, there might be a standard. How many bytes is each one? Maybe 4 bytes. I'm not sure, but it's not a lot of memory to use to just send text. So terminals were the beginning of using computers, and eventually, once we had enough memory, we then built graphical interfaces on top of it. So if you want to think about how your computer works, just imagine the desktop as an abstraction of this terminal usage, right? And the terminal usage, by the way, of course, is also an abstraction of just like literal transistors that are on and off with different addresses, with numbers that correspond to other numbers that correspond to other numbers. These are all abstractions to help us use them. But if I go to my desktop right now, there is a folder here called Linux testing, which I just created. And inside that folder, we have a bunch of files, right? So what it's doing right now is you can imagine it. When I clicked on the folder, it said CD Linux testing, and then it hit ls. And then for each item in the ls, it runs a program that figures out what kind of file it is, and it makes like a little icon, the C icon here or the folder icon there, right? It gives me all of these details. This is a program that someone wrote for Windows to display what's on your hard drive, which is a really cool way to think about what's going on in your computer. It's just kind of nice to understand how that all works. So terminals are very cool. The last thing, I think this is the actual last thing, is editing your files on Grail. So I went over this quickly, but if you are a Visual Studio Code user, you can connect directly to Grail if you have an account through CSU using the remote window. So you can refer back to this whole workbook, this workshop book. I will show the QR code at the end, but I will just go through this quickly if you would like to follow along. If you open up Visual Studio Code and you click on the left bottom, there should be a friendly green button down here. This says Open Remote Window, yeah? And click on Remote SSH, Connect to Host. It might have to install this if you've never done it before. And then you can type in spirit.eecs.csuohio.edu. But for those of you who've used Grail and Spirit before, you need to write your username. So for me, it's memaneve at spirit.eecs.csuohio.edu. And it will open up a new window. And this is connecting remotely to the CSU computers, and it asks me for my password. I'll put in my password. And boom, it is opening up, connecting to Spirit. And this is the Spirit terminal right here. This is what you've used before in 340 if you've done that. If I want to see all of my folders, it will then, instead of doing CD and LS and all of that, Visual Studio Code will do all that for you visually. So if you click Open Folder, it will ask you what the file path you want. This is just the default file path, so just click OK. You'll need to put in your password again, so give it a second. Let it load up, password. And take a look at this beauty. Move my camera. I don't need to install any extensions. Thank you very much. Look at this. This is my files on Grail. So you can notice CIS 340. Those of you who have been in there, your assignments are usually named something like this. Those are all of my assignments from last semester. This is the Pintos operating system that I'm playing with right now. This file that's open, keyboard.c, this is on the Grail computer, or I'm using it on Linux, but on Spirit, which you're not supposed. Please don't use Grail to do any of this. As you know, Grail should only be used for the turn-in command, and please adhere to that. Since so many people use Grail, we don't want to crash it. But use Spirit or another computer. This file is not on my computer. And if I edit it, it gets saved to Spirit. And then I can run my files here using the GCC, which is just amazing. So this is a great way that I didn't actually know about until recently. A great way to edit your files instead of having to write them locally and then, SCP and all that. You can create new files here too. It's really, really wonderful. So this is good. If this was a little bit too fast, feel free to take a look at the workbook later. There should be screenshots along all the way. So that's the situation. And then let's go back to the workbook. I think that should be it. Yeah, here's just some documentation for those of you who forgot how to do submitting assignments on Grail, but this I'm not going to walk you through. You should have learned this in class, and this is just here for your reference in case you need it. And that's it. Thank you for joining the Linux and Git workshop for the spring of 2025. This was a lot of fun. Be sure to check out the Git recording if you're curious about Git. It's a very, very important technology for students. And like, honestly, if you're ever going into computer science, everything's built on Git. Like GitHub, it's in the name. Everything's built on Git. And you can run Git directly in VS Code, and it just tracks all of your changes and all the file management. It's really, really important. So take a look at the Git workshop. Have a lovely week. Cheers.